shit, pumping and dumping, manipulate the market, flood it from the darknet, flood it from the deep web, keep it a secret. Every exchange got the nerdy brains trading on the frequent.
Alright, let's see if we can do this now. Finally, let's switch to face. But, alright, give it a couple of seconds. I just want to make sure the audio is coming in fine and everything because, ooh boy, very simple reason why we had a delay because I'm convinced we're just never going to have something where it's not delayed. I was like ready on time and everything and then... Okay, perfect. Alright. Hi, we're finally live streaming. Hydration. Don't worry, I'm not dying. I've come under the weather of something for the past week, hence why I have the mask, so I'm going to be like coughing into it. But don't worry, it's not COVID because I literally took the test earlier and it's negative, so it's just me being all weird. Hi everyone out there. I apologize for the super late delay. This was the stream was supposed to start 2 hours ago. Long story short, we had everything ready to go at like 7:05, and then there was a browser incompatibility issue, which is something that I've been having lately, where I had to switch to an older version of Firefox in order to make sure that GitHub properly showed up, because without it, you wouldn't be able to see anything, like we wouldn't be able to audit the code. So that was a whole insanity, and it literally took like an hour and a half of testing of different versions until I finally got to the version. So we'll be using this version from now on to do browser stuff until we're able to fix some issues and everything in here. Mainly, which I'm hoping to do in the next couple of months, which is to get a completely new streaming laptop so everything can just run better and smoother, better camera and everything like that. So regardless, hi everyone out there on the interwebs. Thank you for tuning in. For those of you who don't know, my name is Sidepocket. That's why they refer to me on the internet. Why am I getting dry mouth every time I stream? I don't get it. I'm a millennial. I need to hydrate more. But people refer to me as Sidepocket. I'm one of the two co-founders of DCG 201, formerly known as DEFCON 201 or DC 201. We are one of the many computer hacker groups that the subset of DEFCON groups that take place across the United States around the world. And if you want to know more about us, because we're still working on the website, although we finally have some good announcements to do in the next week or two, so that's great. But you can go to our Medium blog. We're going to be posting a lot of stuff later on this week, probably around Friday. And if you want to follow us to get proper alerts, because sometimes we say we're going to go on and then fuckery happens and then this. So if you want to follow us on our social medias, we're on Twitter, because we're not calling it X until Elon Musk stops dead naming people. But we're also on the Chad Mastodon under hostux.social. We recently joined Blue Sky. We're on Instagram. We're on GitHub. We're on all sorts of things. And you can go to that Linktree link, including different variants of our streams, which, as I'll be saying throughout the episode, if you do like the stuff that you are seeing today, you can follow us on our 5 current streams, although we are going to be switching things up the start of the new year, plus also Happy New Year if I haven't seen you for Crypto Barons before. But you can go follow us completely for free on Twitch, YouTube, PeerTube, Odyssey, and Kick. If you follow us on everything but PeerTube and Odyssey, we get notifications and cheer you on. There's an even cooler way for us to cheer you on the entire episode, which I will get into a moment. But in addition to just helping out on the channel by just subscribing to us completely for free, you know, we're always ad free and everything like that. We don't do sponsorships and things, so you know we're talking straight from us. But we also you also will get alerts on those streaming platforms when we actually go live, so that's also very important. And we're going to be using it starting in February for various activities, for both conferences and CTFs. But if you want to communicate until we set up our new IRC channel and our own private chat, we do have a Discord, so that's a Discord link. So it's still going on. It's going to go, so far it's still going to go on until, like, basically once April 1st happens, so start of April, that's when the whole thing's over. So that's when this whole thing's gonna go on, and I will get into that in a moment. But because we have a lot to cover, and I started really late, I just want to get into all of this, and then we'll talk about that. But thank you for bringing that up, Zeph. Um, in addition to live streaming our meetings, which when we get back to our meetings in probably March, although I might try to sneak our first return one in February. We also do a bunch of live streaming shows and specials. And it's funny because something that I'm going to post on social media today is that today is, let me bring it up on here on the calendar. Today is Digital Privacy Day. So yay for digital privacy. Support the EFF, support Access Now, go to privacyguides.org. Learn how you can be more private and secure in your area. Learn about legal stuff because there's a shit ton of draconian laws. There's more draconian laws passed now than I think in all of the entire Bush era, which is insane. Basically, George W. pissed on all of us so that, you know, Trump and Biden and the United States government, never mind other world governments, could all shit on us. So, you know, there you go right there. But happy, you know, Data Privacy Day. Hope you educate yourself. Hope you harden your security. And yeah, a little cool tidbit. But I do 2 live streaming shows. One of them's called Master of Unlocking, which announced about that because of cool factor to make it extra awesome. I delayed. We normally stream. I do a show. Both these shows I do twice a month. I had to basically we just decided not to do another Master of Unlocking for this month. And the first one's going to happen, if everything goes right, on February 10th. And the stuff we're going to do there was a reason why we delayed it, because it's going to be really cool. I can't wait to announce the little wrinkle we're going to be doing for that. But that's the lockpicking show. This show is called, let's see if I can block it out here. Hold on. Wrong arms. There we go. This is Crypto Barons, where we get to look at cryptocurrency and blockchain and Web3. I hate that name. But we look at blockchain tech. And I do mean we look at blockchain tech. We review white papers. We do math in white papers. We explain how cryptography works. We look at the code. We audit code, test nets, wallets, all of that. Sometimes we talk a little bit about economics. Sometimes we talk a little bit about social stuff if it, you know, trying to go over and do OPSEC and recon for what we're talking about. So what we're going to be doing today. But this is very much, if you like, which is why for this episode I decided to put it on for like Twitch and stuff, the like software development side of things instead of the crypto category. Because while this is a blockchain tech, we're going to be doing a lot with code today, which is going to be funny because everyone knows that I'm not the best coder. So, you know, but it seems that the episodes that do really well are where I'm suffering. So I hope we get enjoyment out of that. If we could do what I'm hoping to do tonight, it'll all be for a good cause. So this episode today, what we're going to be looking at is a platform called Aleo. This is something that just randomly showed up, just clicking around on links and just wound up on their page. I think I wound it up through a link on Telegram. It is a decentralized application platform, or a DApp. So similar to how Ethereum, you know, most people know Ethereum as you making applications in your own coins. You can do a similar thing to Aleo, but Aleo has very unique properties, which is why I decided to cover it, such as revisiting ZKSnark, something we haven't covered since the first year we've done this. And basically, we're in our 3rd year of doing crypto barons. Isn't that crazy? Like, by the time May comes around, it'll be our 3rd anniversary of this show. That's insane. And we have a lot of stuff that we want to cover. But we're revisiting like cryptography with ZKSnarks. It's focused on private and security, allegedly, including having an audit by the Trail of Bits people, which we're going to go over. And it has its own programming language called Leo, which is based off of, Rust. So we kind of get to explain Rust and explain its programming language. So it seems that our stream is popular enough that once again the terrible bots come in. And that reminds me of something as I tell this person to fuck off. The thing did an update. Let's just repost like the blog and everything like that to get this nest. Oh, okay, it reset it. But basically, I love a lively chat. If you have any questions, such as why we're fucking super horribly late, why am I wearing a polka dot shirt when I'm talking about a completely different blockchain platform, what's Wikidata, what's being a hacker, what's DEF CON, things like that, my facial hair, why do I sound like I have 2 socks shoved up my nose, ask away in chat, as long as it's not a lame troll or like bot ads like you just saw that we blew off. And but if you are just here to watch and learn, Keep lurking, keep learning, as I always say. So without further ado, because I really want to go home at a decent time today, let's go to today's episode. So let's go to the browser, because now I got it to work. So this is our Medium blog. As you can see here, we have a bunch of different things that we've been kind of filling our time talking about, like other conventions and things. And yes, we will be bringing back the Hacker Summer Camp guides. We're going to be covering 3 months worth of cons again, and it's going to be global, and it's going to be a goddamn circus. We sort of gave a preview of some of the old places we're revisiting, including DEF CON 32, but we're also adding some new conferences that we've never covered before, and subjects we've never covered before, in countries and places in the United States that we never covered before. So that's going to be fun. Okay, so just popped in here because this is like a server utility room. That happens, which is funny because now I'm going to bring up that I want to thank the folks at Hack Manhattan for hosting us here, because without... I recently just joined this hackerspace. In fact, I should wear the little badge pin I have one day. But they're a really cool hackerspace that's in New York City because unfortunately after Maker Bar literally went up in flames, I'm not exaggerating, there's really no hackerspaces left in North New Jersey. I've had people ask if DCG 201 will do one again, and we were on our way to that until the pandemic hit. So I would say give us about 3 or 5 more years and we'll see what's going on. In the meantime, Hack Manhattan is an excellent space, and they never asked me to advertise this. This is just me like just being happy that I'm able to consistently do the live stream instead of the dark ages that I had like a year ago, where I was in random coffee shops and corners of the streets and stuff, and you got to hear dumb sounds, and we get DMCA'd because people would just be blasting music. But they're a really cool facility. It's located on 37th Street in Manhattan between 5th and 6th Avenue. If you are from Jersey, like I am, you just take the PATH train to 33rd Street Station and walk from there. You can take the orange or yellow line trains, the F, the M, the N, R, and stuff, to 34th and walk, or just go from Times Square and go down. They do everything there in addition to like super dork STEM nerdy stuff like coding and robotics, and they also have hands-on stuff like woodworking and metal working. They do a lot of soft stuff like sewing and D&D games. It's just a really basically if you're a dork and you like doing things, Hack Manhattan is great. And they have an open house every Tuesday and Thursday starting at 7 p.m. It's technically supposed to end at 9 p.m., but it usually goes on way longer than that. And every second and fourth Tuesday of every month, I teach lockpicking there for free. So if you've ever seen The Master of Unlocking and you're in the area, the New York metro area, which includes New Jersey, and you've ever wanted to learn in person from me like you do on that show, you can show up on the second and fourth Tuesday. But regardless, the open house to visit whenever is on every Tuesday and Thursday at 4 p.m. And again, they're located on 37th Street in Manhattan. Great place. Thank you so much for letting us use this facility here for DCG 201. I just realized I could see Chaz in the corner. And this last thing before we get into today's episode is kind of the big thing that I wanted to focus on here, as someone brought up in the chat earlier, is that we have been doing a charity run since the beginning of December. It's going to end when April comes around, so we're doing this we're like halfway through. And we're also almost halfway through our donation goals, and it's for Doctors Without Borders, because as you know, there's the whole Israeli-Palestinian conflict. And regardless of what side you're on, I mean, for me, I'll put it this way, background, because we had to make a statement about it. Fuck Hamas. Hamas is a terrorist organization in the same vein as the Muslim Brotherhood or the current U.S. Republican Party. They're fucking awful. October 7th was awful. But Israel's retaliation, instead of going after Hamas itself, like sending in like actual teams to shoot the soldiers, they're just leveling just everyone in the region, including countries that had nothing to do with this. And that response is even more horrifying, in my opinion. It's kind of similar to how like 9/11 was awful for a lot of Americans, but it did not justify all the stuff that we did to our citizens and citizens abroad when we invaded, particularly Iraq for the second time. So I more lean towards the Palestinians, but whatever side you're on, Doctors Without Borders is helping everyone that is injured and sick, because it's not just bullets. Infrastructure has been destroyed, so there's a lot of, particularly kids and women, getting sick and dying And to show you how awful the Israeli Defense Force is, they've also shot their own Israelis who are actually fighting against Hamas, like the citizenry. They have they basically beheaded themselves to spite their face with a lot of policy and infrastructure stuff that's also making their own citizens sick. So I feel that just donating to these doctors who completely run out of donations and volunteer their own time, going up, not they don't get any payback. It's just this is very important. So if you'd like to donate, if you want to knock the Murph off the leaderboard and donate like $50.50, go right ahead, or like just put in like $1 billion. But most of the time when we've already gotten as halfway as we had, donating $1, $5, $10, that sort of thing, just any pocket change you have, always has reached our goals when we've done live streaming in the past. So I'm going to be constantly bringing this up throughout the streams. It's sorry to be annoying, but like, people are fucking dying and we're hackers. We like to fix shit, so this will help fix shit. If you want to donate, I just put the link directly through Tiltify in there. If you're on Twitch, we have a widget so you can donate without leaving the website. And if you notice in the lower left-hand corner, there's a QR code. I promise it's not a man-in-the-middle attack. If you scan that, it'll bring that up on your phone so you can continue to watch me suffer trying to code and explain cryptography, and you guys can donate to a great cause. Note about Tiltify, unlike other scummy charities, we don't touch any of the money, so it's completely handled through Tiltify, and they also take fiat and crypto. So there's really no excuse. If you have any form of currency on the planet, digital or physical, you could donate that. And even if we don't meet our $200 goal and the overall $400 goal for this project, all the money will still go to Doctors Without Borders to help injured people, injured and sick people, particularly sick kids in Palestine and other parts of the world. So that's what we're doing. So without further ado, let's get into what we are here for. By the way, this is also the Doctors Without Borders website explaining what's going on and stuff. I should have clicked over there when I was talking about them. So anyhow, here's Aleo. Randomly found this page through a Telegram link. I'm going to probably try to stream until like 10:30 or something, so like an hour and a half. And as they say here, and I think the headline really sums it up, is zero knowledge with uncompromising speed and privacy. I know it sounds like, they want to have their cake and eat it too. I have 3 videos we're going to be watching throughout the episode, so let's load up a video. Very interesting. They don't have a video or a short video that explains exactly who they are. So normally we like watching videos from like projects just because it's great recon to see like how an organization views itself and also how they want to be seen to the public. But the most of their videos are very focused on like develop coding, new module functions, things like that, which already shows you that this project's really hacker as fuck. They're not fucking around. They're not talking about bear markets and buy the drip and bullish and stuff. They want to see results. They are way more focused on building stuff and then you figuring out how you're going to make the money on it afterwards. So I found a little interesting third-party video that we're going to take a watch at that explains in plain English how what Aleo is, with its old logo, I might add, and how all it works. So take it away here.
Hello everybody, in today's video I'll tell you about Aleo protocol, how it works and what problem it solves. At first I'm going to explain you the current privacy problem we currently have on the internet. Then I will show you how blockchain tried to solve this problem and why it doesn't work perfectly. And finally I'll tell you what zero knowledge proof is and how Aleo solves privacy problem. Let's go! A decade ago, the extent to which we rely on the internet now would have been hard to imagine. Today, however, the majority of our economic and social activity occurs online. The benefits of this change are especially clear amid the COVID pandemic. Businesses that never relied on the internet before are using it to reach new clients and customers in order to remain afloat. Families are using it to stay connected while physically distanced over the holiday season. The consequences of living our lives online is the exponentially growing amount of data we produce. This has been a major driver for better products and better services. But the power that these algorithms and their owners wield through feeding us the news we read, the shows we watch, and the social connections we make cannot be overstated. This trove of data produced by our online interactions has led to the creation of a new economy defined by who owns access to this data and who doesn't. This intangible data economy is massive, larger than any commodity, including oil, and just like oil in the early 20th century, data has grown increasingly centralized in the hands of a few companies. These data monopolies not only pose threats to data privacy and censorship. Monopolies are bad for economies. They encourage rent-seeking, stifle growth, depress innovation, and harm consumer welfare. The state of today's internet is a few monopolies that collect vast amounts of data yet fail to deliver a personalized user experience. But how can we expect to fix this without being even more liberal with the data we share? Blockchain technology was, from its inception, architected to be transparent by default. This architecture is a sharp contrast to today's Web 2.0 defined by closed ecosystems owned by corporations that profit from information asymmetry. It would seem that public blockchains eliminate the unique information asymmetry that support the current monopolies of Web 2.0. But in fact, networks that establish transparency by default create their own kind of information asymmetry that costs network participants and demands a solution that is sustainable. Transactions on a public blockchain are visible to everyone, whether they are active participants on the network or not. The fact that these networks are open prevents any single entity from monopolizing user data, as Web 2.0 monopolies do today. However, this opens up new problems. Any person can look at your balance, can find out what actions you are taking. And if someone manages to identify a wallet with some kind of personality, he will be able to know the entire history of your transactions. Worse, it creates opportunities for other network participants to profit from the information we reveal through our transactions. This is not theoretical, it's costing users money today. In short, anyone using a public blockchain network is vulnerable to opportunistic actors in the system. Decentralized networks are vastly fairer than those available through centralized alternatives. However, the examples of front-running and MEV cited above illustrate how information asymmetry still leaves a cost on users in decentralized systems. With a public network, we may have removed the centralized gatekeepers. But now we find ourselves in the dark forest facing not one, but potentially many potential adversaries who could exploit and use our data at our expense. A naive approach to solving this asymmetry on public networks is to hide everything and make the system fully private. But absolute privacy eliminates one of the most significant benefits of an open network – composability. In an open network defined by data transparency, smart contracts can autonomously interact with and access any on-chain information. The DeFi ecosystem, DAOs, and other composable contracts all rely on transparent access to data. Networks that establish absolute privacy by default ensure that no data can be exploited, but also preclude the creation of the incredibly powerful decentralized applications that define why crypto is revolutionary. For example, Zcash gives users complete privacy but limited programmability. Ethereum provides powerful programmability but limited privacy. What we would like is a protocol that is both private and programmable. Such a protocol would ensure that users are not exploited, yet enable powerful on-chain applications and composability between them. This is why we built Aleo. Aleo is the first decentralized open-source platform to enable both private and programmable applications. Through opt-out privacy by default, Aleo enables a sustainable, equitable Web3 world that can meet developer, consumer, and enterprise needs. Aleo uses zero-knowledge cryptography to achieve both privacy and programmability. Zero-knowledge cryptography and zero-knowledge proofs allow third parties to verify the truth of a piece of information without us needing to reveal it directly. Aleo uses this at the foundation of a system called zero-knowledge execution. In ZKSnark, users execute state transitions offline. This process produces a proof which is bundled into an on-chain transaction. This transaction updates the state of the system by consuming, creating on-chain records. Like Zcash, the system gives us strong privacy guarantees, as the transactions contain only the proof, not the input that generated it. And like Ethereum, ZKSnark can support smart contracts that enable users to interact or transfer value in a predefined way. For example, let's say you want to trade token A for token B on an Aleo-based DEX. First, you will need to prove to the DEX that you have enough of token A in your possession to complete the transaction. But because this information can be shown through a zero-knowledge proof, this doesn't mean revealing your wallet balance or trade history. Instead, you can reference in an on-chain proof a record of a prior transaction to show that you have a sufficient balance to trade. In the process, the exchange never learns the amount of tokens you own, where you got those tokens from, if you ever transacted on the DEX before. Altogether, this creates a DEX ecosystem that is not only entirely private and scalable for users, but also replicates a key feature of smart contract blockchains like Ethereum, composability. Some more examples. Imagine a situation that Bob wants to buy alcohol in a bar and the bartender asks him to show documents to make sure that he has enough years for this. He shows him his passport and the bartender sells Bob alcohol. But when Bob shows his passport, the bartender gets access not only to information about his age, but also learns other data, full name, ID, etc., such information that Bob wouldn't like to share. Zero-knowledge technology will allow him to independently choose which data he wants to make available and which not. In this situation, the bartender would not have learned anything superfluous about Bob. He would only understand that his age corresponds to the need to buy alcohol. Here is one more example. Suppose Bob wants to take out a bank loan to buy a house. The bank collects a large package of data about the client, and as a result, special algorithms form a credit rating, on the basis of which the bank decides whether to issue a loan or not. With zero-knowledge proofs, the bank will not see any extra information about Bob. They may not even know that his name will be Bob. What they will see is that Bob's rating corresponds to the minimum required values. Let's summarize. Aleo is a blockchain that allows using zero-knowledge proofs technology to preserve the privacy of users as well as to create an opportunity for developers to create modern dApp. Users have never had such opportunities to control personal data in the entire history of the Internet. Aleo gives full control over the input and output data that users will generate when interacting on the Internet. Aleo has also created a special environment and programming language that allows developers to easily implement this solution into their existing products as well as create completely new ones. Thanks for your attention. Follow the news about the project by following the links down below.
So I thought that was a decent summary about now, every time I've seen videos, I've heard them pronounce it Aleo, not the way they pronounce it in the video. And again, this wasn't from like their official website. This was from like a third party describing it, so whatever. But I think it's a good summary of like all the key points about Aleo here. And so some of the things that they really wanted to highlight is low complexity, so it abstracts away low-level cryptography so developers can build private innovative applications. It has allegedly built-in privacy, which is something we're going to go into in a moment. Similar to Ethereum, it has very high scalability through their Snark VM system that we're going to look at later. It also has unlimited runtime for secure off-chain computations. That way, everything's not reliant on like super gas fees, and you're able to just test stuff without having to like constantly having to make alternate test nets for everything. Absolutely decentralization with its Snark OS platform, which again we'll go later, and increased data security. Now, the way it achieves its main security, because you probably noticed this word called snarks, is that it's using a type of technique called ZKSnarks, or more full word commonly known as zero proof knowledge. And many episodes ago in our first year, we covered, I believe, like actual cryptographical security coins back in the day. Some of those are probably outmoded. We should probably do a follow-up episode eventually. Maybe when we cover finally stable coins, which is an episode I've been pushing off forever. I went and I had like a whole diagram and trying to explain what ZKSnarks is. But just know it's a type of encryption technique that allows you to do Alice and Bob like stuff in a very unique way that is not done in like a PGP sort of way. And again, especially with my current like condition all week, I'd probably butcher it. Like I almost did the episode when I cover it. So I promise, because we're gonna get through all these videos right in the beginning. Here's the second video we're gonna watch. We're gonna watch this amazing lady from CoinGecko explain ZKSnarks way better than I can. So here we go.
Hey there, imagine this. You have a top secret code that opens a mysterious door in a cave. You're willing to sell the code to your friend Jerry. However, you want to prove to Jerry that you have the code without revealing it in any way. Well, wait a minute, is that even possible? Well, what if we told you that it is? Through a method used in cryptography known as zero-knowledge proof. It is a way of doing authentication to prove that something is known without revealing directly the known information. All right, let's get into it. So this concept was developed by a group of mathematicians in the 1980s and has been used by various cryptocurrencies such as Zcash, which, unlike public blockchains like Bitcoin, gives you the option of confidential transactions and financial privacy through shielded addresses. So that seems interesting, right? Well, then let's get back to our mysterious cave and see how this whole concept of zero knowledge works. All right, note that since you have the code and you're trying to prove that you do, you are known as the prover. Jerry, on the other hand, is trying to verify that you indeed have the code, and so he is known as the verifier. Now, things get interesting here because in the cave, you find that there are two different entrances with paths that are connected with a door. This provides the perfect environment for you to prove to Jerry that you have the code without revealing it to him. Jerry goes to the entrance of the cave but has to wait outside to give you instructions. Let's name the entrances A and B. You enter at random through one of the entrances while Jerry waits outside to tell you which path to exit through. If you really had the code, you would be able to exit through the path that Jerry wants every single time by using the door. But mathematically, you would have a 50% chance of picking the right entrance and path from the get-go. The best thing is to run the test again and again to reduce any chances of luck involved. Now, from this example, you're able to use the same proofs to verify that you have the code by opening the door and coming out through Jerry's requested path multiple times. In this sense, your proof system aims to achieve statistical soundness, completeness, and most importantly, zero knowledge. These are the three main criteria that a zero knowledge proof method must satisfy. So first, soundness. So soundness in that if the information provided by the prover is false, then a ZKP method must allow the verifier to refute that the prover is telling the truth. If Jerry asked you to come out through path B, but you came out through path A multiple times, or even just once, it could mean that you don't actually have the secret code to the door. Then the second criterion is statistical completeness, which implies that if the information provided by the prover is true, then a zero knowledge proof method must enable the verifier to verify that the prover is telling the truth. Simply put, everything that is true has proof. In our illustration, this would mean that as long as you come out through the path that Jerry indicates every time, then it's very highly likely that you have the code. Now, the third criterion to be met is zero knowledge, such that the method must reveal to the verifier nothing else than whether the prover is telling the truth or not. In our case, the only information revealed is that you were able to go through one entrance and leave from the other because you have the secret code. In no instance did you reveal to Jerry the secret code. By the way, the example that we've just covered is an interactive zero-knowledge proof method where the prover and the verifier interact several times until the verifier is convinced. The other type is known as a non-interactive zero-knowledge proof, where proof can be delivered offline without direct communication to the verifier. Now, regardless of the method, zero-knowledge proof in general has its advantages and its disadvantages. So, advantages include simplicity, since it does not require complex encryption methods. ZKP also reinforces system security and privacy. The zero-knowledge proof method strengthens the security of information by replacing ineffective authentication methods. Now, similarly, it increases the privacy of users by avoiding the reveal of personal information. Now, that said, it also has its drawbacks, like the need for a large amount of computing power. In interactive ZKPs, where many interactions are needed between the prover and verifier, computationally intensive algorithms are used. The same goes for non-interactive ZKPs, which require advanced computational capabilities, making ZKPs unsuitable for slow devices. The other challenge is that ZKPs don't give a 100% guarantee that the prover's information is true, mathematically speaking. Now, in our example, we saw that as you continue to exit the cave as per the path requested by Jerry, the probability of you lying about knowing the secret code decreases with each iteration. However, it can never reach zero to give a 100% guarantee. So then what about its applications?
ZKP has already been applied in many industries, including crypto.
For instance, Zcash uses a type of zero-knowledge cryptographic method to introduce more privacy to its blockchain. Unlike public blockchains like Ethereum and Bitcoin, it provides complete privacy when it comes to transactions. Zero-knowledge proof is also applied in sectors such as finance.
The ING Bank uses a type of ZKP that allows users to prove that they have a secret number that lies in a known range.
For example, a mortgage applicant could prove that their salary sits within a certain range without revealing the exact figure.
ZKP can also be
applied in authentication, where users can be authenticated without exchanging secret information such as passwords.
Overall, ZKP is a concept
that points us in the right direction technology-wise, especially in this digital age where platforms collect our data and sell it for profit. So, what do you think of zero-knowledge proof? Do you believe it will catch on going forward? Well, let us know in the comments. And of course, remember to like, subscribe, and follow us on all our socials.
So again, I think that's a great summary of what zero-proof knowledge is, but to kind of more elaborate on it, as I showed with the example, it's also in the name, it's zero-proof. And by proof, they mean that normally in a lot of cryptographic exchanges, you would have to look at the actual key data. If we're using physical locks, for example, a actual like proof of knowledge would be looking at the key bidding and then knowing the bidding in the doorknob and then being able to compare of, okay, the key bidding heights are the exact same bidding heights as the doorknob, which would allow it to pass through, and then you are let in. You know, again, it's like having a written password and then someone else has a password, they say the password that matches your pieces of paper, and that's how you know. With zero proof, what they're doing is that instead you have the key, you never show the key, but you're asked to go through the door. And the idea is that because you're allowed to go through one way through the door, but not the other way through the door, that means it's very likely, because you've proven that since you had the key to go through one way and you could go through the other way, that means you do have the key to go through that way, and therefore that proves who you are. I guess the equivalent would be like kind of knowing what cards are absent in the deck, so it kind of try to figure, oh, they must have the cards that aren't in there. Now, of course, again, is it perfect? No. One thing they covered is that, again, because it's abstract, you can't ever get mathematically close to like complete 100% proven. Another thing, if we want to use physical security as example, is What if that person picks the lock or bypasses the door? That's them proving they get through the door, but they didn't have the key bitting. They just exploited a flaw in the way that door was set up. You could do something similar to that digitally. There's issues there. But thanks to things like Zcash and other more security coins, zero proof knowledge gained traction. And honestly, because of the crypto traction, despite this thing invented in the 80s, it's now starting to get more traction in general programming on the internet, whether it's AI, general cryptography, message systems, things like that. And in crypto in particular, let's see, so 1985 was the first zero knowledge proof, so the paper that was called Knowledge Complexity of Interactive Proof Systems, which was done by Shafi Goldwater, Silvo Mackay, and Charles Rakoff. I'm very nasally and I'm an American, so I can't read very well, so sorry if I butchered your names, but I thought I would be able, I like to give credit where credit's due. In 2012, Asudro and Shinsei team coined the term ZKSnarks. I always say it like the way that weirdo character from Thundercats does. And 2016, Zcash is the first that popularizes, not the first to use it, but it's the first that popularizes using ZKSnarks in cryptocurrency. So, for example, with Zcash here, it proves its verifiers must interact few rounds for the verifier for proven honesty. Also, again, that takes up computing cycles because you have to make people do this. You have to make the process do the same thing over and over again in different variants to abstract the proof of it. So like instead of just showing a password once and getting through, you have to like do this multiple times, and that both takes time and energy. In ZKSnark, interaction is taken out, so proofs become more complicated. There's a trusted setup to the system. The information used as startup, that's another flaw. If it falls in the wrong hands, if you know how the doorways are set up, can corrupt the entire system. This actually happened in Zcash, where there was a vulnerability that was discovered that because they figured out how the pathways went, they could constantly go through the same doors and thus would be let in and be allowed to constantly generate Zcash cryptocurrency, which is a problem because one of the unique things about money is that while a bank can issue it, the idea is that you should not be able to just replicate it on your own. That's not authorized. That's not through effort. It's you can't just abracadabra this shit. Otherwise, it loses value. You can disrupt the system. So that's another issue there. Let's see here. So yeah, that's kind of the overall thing. Again, if you go back many episodes in the first year of of Crypto Barons, I covered ZKSnarks and zero proof knowledge and other cryptography systems and security coins. So go way back to that episode if you want to see that after the stream. But let's get back to Aleo, what it uses for. So it uses for that. Another way it does security stuff is they actually do security audits. It's honestly rare that I encounter cryptocurrency blockchain stuff do security audits. That tickles my fancy with hacker stuff. And what's really neat is that they went through 3 teams, Trail of Bits, NCC Group, and ZK Security to audit both Snark OS and Snark VM. We're going to, in a bit, we're going to look at, let's look at the other 2, and then we'll focus more on the Trail of Bits one. So NCC Group is a world-leading global provider of software resilience for business and continuity solutions. They looked at translating high-level code to circuits that are comparable with the underlying ZKSnark proof system, implementing and execution of the proof system and primitives that are needed to support it, and the actual data structures for storing interaction with the blockchain on the ledger. So they very much looked at like the setup on the blockchain side of it and did that audit. They have all published links here, all on GitHub. Then there's ZK Security that looked at the actual zero-knowledge proof systems and their applications for them, and they also came up with their audits. And the thing we're going to briefly now look at is the amazing PDF by Trail of Bits. I was introduced by them because there's a really cool friend of mine who I don't know if they want to be named by name, but basically met them through the 2600 meetings and met them through, they eventually became a member of Hack Manhattan, so they're actually here right now having fun, unlike me right now, because I have to do actual fucking coding on this live stream. But it's all for a good cause. Again, I'm trying to raise money for the Doctors Without Borders. You can click the donation link in chat to donate, or if you're on Twitch, we have a little widget, or scan that QR code. Again, $1, $3, $5. If I get just one donation during this stream, especially while I'm going to suffer myself coding, I'm just going to be so happy. But they became a member. They work for Trail of Bits. They also help host a whole thing called Empire Hacking, which is another like InfoSec sort of meetup in the city. Really cool. And they specialize in software testing, code review projects, block, and various forms of security. They make their own tools, both red teaming and blue teaming. And they went to their blockchain experts. And let's quickly look at what they wrote here. So here's the PDF. I will actually post the. I'm going to copy the link and post it in chat. And by the way, after we recover the whole base thing of what Aleo is, I'm going to take a break, and then we're going to talk about the Leo language itself, and then get into setting up a local Aleo chain and programming in the Leo language and how it's comparable to Rust. So we're going to be taking a break in a couple of minutes, but let's look at the security assessment. This was done last year on November 28th. This was done by Philip Castell, Opal Wright, Joop Van Die Poel, and Dominic Sazanota. Again, I apologize if I fucked up all your names because I'm an American. I'm terrible at it. It's a little bit about Trail of Bits. They're from New York. They're awesome. You can read the whole thing. Again, look up Empire Hacking. Really cool people. Copyright, blah, blah, blah shit. We have a table of contents here. Let's see. This is remarks. It's a project summary, executive summary, project goals, project targets, blah, blah, blah. Automatic testing, maturity evolution, detailed findings. Let's see some of the detailed findings. Denial of service vectors by implementations. Faulty validations enable more than the intended number of bits. Wow, they found a lot here. Missing upper bound validations with max struct entries, which is basically the whole validation structure. That's kind of fascinating. The test 3-node API endpoints provide a binary path repository information, which is, it's open source, but you kind of want to reveal that on the network end. That's kind of a problem. Maximum peer message limits is off by 1 because, numbers are fucking hard. The peer request response flow allows for a local IP with non-node port. Sure, an IP is not great. Again, they found a ton of stuff, and the whole thing is not to scare you of like, oh, this is horribly insecure. Every company who's worth their salt, like Proton Mail does this, they have their stuff publicly audited. And that's something I actually like overall in the blockchain space, is that most of the companies and organizations and hackers want you to find mistakes because they actively want to improve their stuff. It's a fucking godsend because I grew up, and I still grew up in a field where even if you try to properly report bug bounty things to Microsoft and Google and HP and other terrible fucking companies, they will then just send fucking snipers at you to get rid of them, and then they sit there shocked Pikachu face of why this shit leaks on the internet, because if they behind the scenes worked with the hacker to patch stuff, there wouldn't be an embarrassing PR goddamn log4j bullshit. So if there's something, cryptocurrency is full of fucking scams and terrible stuff, but if there's like one of the very few things I can give about the seed, most of them, except for 3 that we did on the episodes, and you know who you fuckers are very open to change and, auditing. And while I'm at it, let me post the link again for the Hackers Hackers for Palestine, the whole Tiltify donation link again. We don't touch any of the money. It goes straight to Doctors Without Borders. Even if we don't make our goal, all the money that's currently raised and will be raised by April will go directly to them. So I'll put it this way. If someone donates $1 during this stream, I'll be fucking over the moon. And by the way, when you donate, I cheer you on the entire episode. So instead of just being like, oh, you followed us on Twitch, yay, and then go on, I will worship you like the way I worshiped Murph when he donated that fuck ton of money throughout the entire episode. You don't even have to, if you knock Murph off his fucking leaderboard ass, I will like super worship you on the stream. But even if you just donate, you're going to go in there, and at the end of the whole charity run, we're going to list, even if it's an anonymous donation, everyone who donated as a giant thank you. So just cool shit. Also, again, you could, if you are worried about big bang centralization, dumb shit, stuff that now like fucking terrible politicians are trying to milk to desperately get votes, but you have a lot of crypto that you don't need anymore, you could also donate in crypto through the giving block through Tiltify. So you have no excuse. Put it that way. I've already donated some stuff as an anonymous donor. You have no excuse. So love to see a donation. But yeah, let's get back to the audits. Let's just cherry pick some things. Ooh, proof of concept for, all right. Let's look at some things, some contact information here. Engagement overview, Aleo system, engage trail bits review, security components of Snark VM and Snark OS review of Snark VM. Focus on the synthesizer and finalize construct logic handling of the review of Snark OS. Focus on the internode communications and the implementation of the DAG-based consensus protocol. Bullshark, which I almost read as bullshit, which I'm pretty sure is the point. A team of 4 consultants conclude the review from August 21st to October 6th, 2023, and 18 engineer weeks of effort. Their testing focused on ensuring the robustness of interfaces, handling unvalidated data, and finding discrepancies between specific specifications and implementation, which is very thorough. With full access to source code and documentation, perform static and dynamic testing, as I said about like the online and offline stuff earlier in the video. The code base using automated and manual processes. Okay, Trailer Bits doesn't fuck around. I definitely give them credit with shit. The observation overall, they found the code base is generally very robust to malicious or malformed data, and that it correctly validates the data structure it handles, except for the low severity of finding Tobe Aleo 1. Which could enable denial of service attacks due to missing data validation while decentralizing some data structures. All the other validation findings are information severity, which is honestly, again, they found one major flaw that they elaborated on it probably, which we're going to probably see in a bit told of how you could patch it. The fact that nothing else faltered really, in my opinion, I guess shows like how well this whole ecosystem is set up, unlike Ethereum. I'm looking at fucking Ethereum. Finding Tobe Aleo 21 should also be highlighted. We identified an important function in the consensus algorithm that always returns false due to a typo in the implementation. This reveals that there are some areas with limiting test coverage, especially in more recent developed parts of the code. As we saw with the whole audit, from what I understand, every single thing that they brought up in bugs that they found, including that, I believe have already been patched out. So again, like, this is done very properly. So just going to scroll through some things here. They have different, like, that's the category breakdown, access control, data validation was a ton of patching, testing, cryptography, different severity levels. Nothing was at high. We have one medium, below, informational, undetermined. The project goals were, does the code base follow best practices of Rust? And we're going to get into why they're talking about Rust in a bit after we do the break. In a moment, does Aleo Rust parser match the Aleo grammar specified in grammar.abnf? And again, we'll look at all this code later after the break. Does the Rust implementation match the Aleo protocol specification? Is the Aleo parser instructor deserializers robust to malicious or malformed data, which is very important that the fucking network recognizes that. Are their next block and transaction validation functions properly implemented? Proper implementation is something that we have busted so many, like not just scams, but just poorly implemented systems in the past. Is the Bullshark not bullshit? Are the REST API endpoints robust to malicious or malformed data? And is the internet communications robust to malicious participants? Again, as talked about with the folding ideas video, a lot of stuff in blockchain. A lot of people are like constantly worried about middleman stuff, probably because a lot of hacks in blockchain, like half of all hacks happen on bridges, and people think bridges are middleman things, which they technically are in terms of transactions, but not in terms of an overall like hacker data surface. And what breaks these bridges and what breaks a lot of blockchain is more of bad data going in to on purpose to poison faulty systems than trying to intercept good data that's already been entered in and turning into bad data. It's not changing blocks that are already on the blockchain. It's introducing bad blocks into the blockchain that will fuck up the entire chain. Basically all of that. So it's nice that they're really like providing all of this overview here. Just scrolling through some stuff, see if anything jumps off at me. Again, they're being really thorough here, as I expect from Trailer Bits. Again, really cool people to hang out. If you ever see them at Empire Hacking, really cool people to hang out. They're also a business, but like, especially covering Black Hat, I've had my fair share of fucking the InfoSec motherfuckers, and it seems like, these people just seem like hackers who happen to have a job. So that's kind of neat here. Let's see here. Parsing differences between the Aleo NBF grammar and the implementation. The severity was only informational. They said we have identified several differences between the grammar and the aleo.mvf file and the Rust implementation. Missing finalized output tokens. Oh, that's what happened. They did generate the finalized statements. So basically, yeah, it allows the way they wrote the grammar for it allows multiple output tokens in the finalized statement. But the thing is, there's no implementation there's no output statements, so you can just generate tokens that just shouldn't be there. That's fascinating. Ooh, that must have like kind of stung when the team knows this. Again, this is the type of shit they want to hear. You know, this is how you improve a fucking network. It's kind of sad that just like base sanitation and like testing and hardening and overview is just something that's been just lost to fucking time, just because of how bloated and capitalist everything fucking is. I'm just going to go back to the table of contents if I can, because I want to jump straight to the meat of things. And we're going to talk about what are two other things, take a short break, and then go directly into the code. And again, between like 10:30 and 11, I think we will definitely be done here. So hope I'm not boring you all, because this is really fascinating to me. That's why I wanted to cover all of this. Let's jump straight to the proof of concept for Toby Aleo 12. So this is appendix A, proof of concept that shows the behavior of a refresh underscore and insert underscore function, which causes the issue describing finding in Tobe Aleo 12. So this is the refresh. Yeah, may not return previously seen timestamp. This is the one high security difficulty one that they found that was high, even though the severity was low. So the description is the refresh and insert function should return in the previously seen timestamp if such a timestamp exists. However, it returns a different timestamp if the map size is bigger than its capacity and the fetch key was the first inserted item. So basically, if they scaled it bigger than what its max capacity is, and the first thing that was listed was its key, it will always return a different timestamp than the actual timestamp that should actually show up, which of course is going to throw off the entire like chain function and potentially the cryptography here, because it's dealing with the keys. Appendix C shows a middle proof of concept problematic behavior. Do this behavior. Actually, let's just jump to the appendix. Automatic analysis tool configuration. SebGrep. We use Stack Analyzer SebGrep to search for dangerous API patterns and weaknesses in source code repository. Wrote custom rules to find variants of manual found issues, such as that line with YAML. And they found some unvalidated integers. Manually found one decentralization function that does not validate the value of an integer before using allocated memory, which is the Tobe Aleo 1. We use the following rule to identify the new instances of the same issues. Let me read this and see if I can find it. Error pattern. See here, read LE. Yeah, there's like the two capacities don't match here. Yeah, you can see between the two capacity methods, they just don't match, which is what will make it outside of its file system. And then if it lists the key for the first time in any of this, the whole thing is fucked. Jesus Christ. Structure serialization with the correct numbers on the field. Let's jump back to the whole Tobe Aleo 1 here. Impact. See, we identified several implementations of the fun bytes REL function, which could use unvalidated number of elements to allow a vector for VCE. Oh no, this is the top here. I'm sorry. Let's go back to table contents and jump to the appendix, because PDF is fucking weird. There we go. Figure E1 shows the main.rs file, and figure E2 shows the required cargo.toml file. And then E3 shows the output program, which you can see that the refresh insert called overwrite with the item key value 0 does not return the previous entry. Instead returns none. Okay, so we're going to look at the rs file first. All right, so mask catch size is 4 listed here. We have hash. Okay, max catch size to right. Let's see here. You refresh the map. So that was that, and then this is the proof of concept code. So EX version 1.1 edition. 0.15. And then the cargo files. So let's see, you have an array of Ks for map items. Here we go. Refresh K0 none, because that's when the whole thing hits the fan when you refresh it. Oh, I see. Hang on. Yeah. Hold on. Let me scroll back. Yeah, give me 1 second. We're gonna take a quick break here. Sorry about that, everyone. We just had to do a quick thing in the Hack Manhattan server room. Didn't want to dox anybody, so now we're back. And then we're gonna go on we're gonna look at 1 or 2 things and then go on a short break before we get into the fun coding part where I torture myself. Let me just make sure my microphone is on. By the way, if I'm like glitching or you can't hear me, just let me know, and I'll try to fix all that, because it took like a fucking hour to do the browser compatibility. Ugh. So let's see. Okay, let's see. Okay, so that's So, map catch size is 4. And refresh map, and that's where they declare the key here with this map right :insert. Let me try to highlight it exactly. Key insert value here, so that's the key declare, and then up here is the parameter for its max catch size. And because of how they replicated the max catch size here every time it reloads, and the way the cargo file here with the where your parameters are packages name and version here, when you print out, so K and V, so we put these two variables, 10, 11, 12, 13, eventually it just basically breaks down. Then when you do the refresh, it returns back none. So that's the issue they're talking about here. Let's see, review results. When undertaking a fix review trail of bits, review the fix's implementation for issues identified by the original report. This work revolves around a review of specific areas of code, source code configurations. From November 16th to November 22nd, trail of bits reviewed and fixed mitigations implemented by the Aleo team for the issues for the report. We review each fix and determine its effectiveness. So let's see here. Partly resolved, partly resolved. There's 15 through 16 were unresolved at the time of publishing this. Partially resolved. It's good to see that most of it's resolved, and I guess the partial resolved is just annoying coding stuff. The main unresolved parts were at the time. Sequence function allows U64 max 0 transitions. Requesting more peers may not use newly connected peers. Committee new allows Genesis committees with more than 4 members to be created. And the GitHub client action versions are not pinned because fucking GitHub client. And then index set removed does not preserve the order of the index set. But it's nice to know that the majority of these were resolved, or at least were partially resolved until better fixes come in. And again, it's just nice to see that a crypto blockchain platform actually did not just, and this was just Trail of Bits, they did 3 different companies for their security audit. So even if it's not perfect, fucking congratulations for them. This is showing again that they do take security seriously, because again, everyone constantly thinks of with hacking of creating multiple ingenious honeypots and having all these mirror databases and active network monitoring, all this shit. But kind of like with banks, the even bigger thing you have to factor in is the fact that at some point you are going to get pwned, you are going to get hacked. So what's your exit strategy? What are you doing for prevention? It's one thing to put all these fancy toys in to try to capture hackers because that's the sexy thing to do, but you're constantly auditing your security. Are you constantly reviewing your code? Do you have exit plans for when everything goes foobar? Shit like that. So it's just nice to see, because it's uncommon in cryptocurrency stuff. That's why even there's a ton of things that aren't scams that feel like scams, because they just fucked up the security angle. If you want to see how bad it gets, look up Web3 is going great. Half the articles in there are just stuff that people getting hacked. So that's pretty neat. And to show an example of a utility for something on the platform, they made an ID system called ZPass. So as they say here, data privacy is a losing proposition. The web's technical limitations forces us to choose privacy. Personalized user experience with ZPass, you can deliver both. The old way, they say, is input and share all your personal data and hope nothing bad happens. ZPass way is prove aspects of your identity without showing everything. And there's a little demo here that we're going to do to see how it works. So let's see. Trusted issuer, like an identity provider, business, or government entity, emails you after verifying your data and asks if you'd like to add your data to the wallet. So it's like, identify me as issue a ZPass, click this link. So as long as it's not a phishing link, because that's a vector that I don't think they factored in, you click on it. Wallet will now open, and a ZPass prompt will prompt you to accept. So you have your identity thing, the date, where you are, signature, which is also just not like, exactly where you live, where you were born, things like that. You accept to add to wallet. It's that easy. Now your ZPass is added, ready to use. Next, let's see a scenario your ZPass can be verified. So you're out here on CoinPurse. So your crypto banking company requires you to verify their identity for your account safety. So, I have ZPass. Click Verify ID with ZPass. Your wallet prompts you to approve verification. It shows what it's asking for, which is your age and your citizenship. And if you're okay with that, use ZPass. Once the proof's generated from Zcash is verified, you can continue using the app. No other confidential information is revealed in the process. And that's an example of something they built with Aleo. That's like a kind of a cool thing. And while we might be able to find the code out there, GitHub for it, if you want to see the demo yourself, I just posted in the chat right there. So, yeah. So, and the other thing that they've done, just like every other blockchain thing, especially because they're working on like development for decentralized applications, they want people to develop, they've also made a network foundation. So they now have a whole initiative for grants program, developer educations, and all sorts of stuff, and security auditing, governance, in order to like, that way that Aleo is more in the hands of the developers that use it, instead of like Zuckerberg trying to force everyone to use all their dumb meta shit. Ooh, there's a request there? Hold on. Okay, so there's also, they built an Explorer. So if everything loads properly, and I hope it's not like uBlock blocking this, but we should be able to see like the latest blocks and stuff here. All right, let's try turning on and off security features here. So I just turned that off. I'm gonna reload the page, see if it loads. Also, it just might be like weird network errors because we are pumping a lot of data. Yeah, there's a whole Explorer out here. Seems like it's slowly loading. Let's see. Processing error. Oh, let's try turning that off and refreshing it for the error tractors. It's probably that in Canvas block. Let's try this again. Alright, let's see if now everything will load. If not, then I give up. But you can explore the blockchain stuff. I'm going to post that in chat. So that's another application they did. Again, this is stuff that is standard for a lot of networks that aren't scams, and even some stuff that are scams, unfortunately. And again, they also, through the whole network foundation, they also do have a developers grants program that we're going to quickly look at here. Just posted that link in chat. Let's see here. How are they doing the grant system? So they funded 15 different projects with over $1 million USD worth of grants. You see a blueprint grant, works on components needed in the ecosystem. You have launch grants, which is more expert one, where it's a whole thing for seasoned developers for like just like huge multi-level projects. Some of the fun projects, which we will also look at, is the Leo wallet, Boludi, which is applying ZK game metrics to enhance the classic game of Liar's Dice, which is this thing, and the Leo program runner, which is bringing the power of Leo programs to Python ecosystem. That's interesting considering it's based on Rust, which again we're going to get into in a bit, for simplifying the development process of machine learning applications. Again, I wish my friends from Trail of Bits was here for that. But let me see if there's anything else. So let's see. This is just more of like all the different like ZK privacy stuff that I probably should have mentioned earlier here. Just all the different types of stuff they've made with like games and things like that. It's kind of the crew here. There's some recon. And then the overall way that their platform works is you have stakers, so you lock up Leo credits, which is its token, to help validators participate in the consensus and security of the network. Then you earn rewards by those credits, and I like that they just used Aleo credits and did decide to make something like clever for their tokens, because again, they're not too worried about the economic side of things. They're focusing on developing, so they did like the bare minimum, but good bare minimum, to incentivize developers to get the whole chain system going, and it's just now focusing on the code. They have providers to provide specialized hardware to generate proofs, solve puzzles for those rewards, and then of course the validators. And that's kind of the overall consensus and everything of how the whole ecosystem is built. So I think, let's see here. Is there anything else that we haven't seen yet? Oh yeah, the Leo credits. So the Leo credits work by they're used to create access to blockchain and computational resource space, creating incentives, as we said before, so developers can get like rewarded for their shit. It enables the staking for validators, as well as provide the governance for the mainnet, so that way you can kind of put in like how the project's. So here's sort of a pie chart breakdown of like how the whole like tokenomics things works. Again, we're just looking at it because it is part of the system. And yeah, that's pretty much it. So we're going to take a short break. I need to refill for water. I need to go pee and a bunch of other stuff. But when we get back, if you notice, the whole platform is called Aleo. And the reason why it's called that is because it's mainly built on Leo, which is a programming language that is based off of Rust. And we're going to look into what makes Rust, what Leo is like. And we're going to look at some of the projects that were built under Leo, and then we're going to try to run a testnet and program some Leo code ourselves. So enjoy the music for a bit. I will be right back. I think we will definitely be done by around 10:30. So here we go. I'll be right back to the actual coding, which tortures me. By the way, while I am gone, what will make me happy is if I come back and find out that someone has donated at least $1 or $5 to Doctors Without Borders to help sick and injured Palestinian men, women, and children, as well as Israeli men, women, children, and other disaster areas, including the United States, from all these volunteer doctors that have no budgets besides donations. We're trying to raise money for them. We are literally $15 away for halfway through our goal. We're going to end this whole thing in April, and the end of March into April. And yeah, you can click on that link or the widget on Twitch if you're on Twitch, or that QR code in the corner. So I will literally shit myself if I see someone donate even $1 and worship you throughout the stream if I come back. So just give me like a minute or three. I will be right back on break. See you in a bit. Sorry, for some reason the music stopped. Hang on. All right, we're back here. Here we go. I'm dumb. I didn't realize the mic was off. Anyhow, hi everybody. Take two. This is Sidepocket from DCG 201, and welcome to the show Crypto Barons, where we look at blockchain and Web3 technologies as the actual technologies. We had a short break because I had to go rehydrate and eat a piece of candy and cry in the window and stuff. But I'm happy to be back. I don't know why the music died. I had to turn off that program. I hope it works when we end the stream. But we've been taking a look at a cool decentralized application, aka a DApp platform called Aleo, and its whole setup, and it's basically trying to be like Ethereum, or like on Ethereum is known for its decentralized applications and its development, except they want things to be more robust and yet more secure, and they do different things with that using ZKSnarks and its whole consensus system and everything. And the third big pillar of it, which is why I decided to choose it, and it very much fits our show, is that they made their own programming language called Leo, hence why the whole platform's called Aleo. It's like Agent Smith. But Aleo, which is based off of an existing popular programming language that we've unfortunately encountered before. So now we're going to take a look at that programming language, look at what it's based on, some of the stuff that's built in it. We're going to look at GitHub code, and we're going to see if we can run a couple of things. So that's what we're going to do for the next 15-20 minutes. So let's get to this. So this is Leo. You can find it at leo-lang.org. I'm going to put the link in the chat. And it says, the Leo programming language brings the powerful... I just want to make sure my mic's on. Okay, my mic is definitely on. But that Leo programming language brings powerful blockchain native syntax, robust error handling, and a private by default, quote, safety model combining performance, reliability, and security in blockchain development. It's interesting because you usually see this type of stuff being really dominated by Solidity. So it's really interesting to see a different type of sort of language for this type of system. So there's multiple IDE plugins for Leo. You have Visual Studio Code, Sublime Text 3, and IntelliJ. And Leo is a functional, statistically typed programming language for private applications designed for intuitive Aleo blockchain development. Leo lays the foundation for a private and decentralized ecosystem. And there's multiple different things that we're going to kind of look at here. And the first thing we're going to look at before we get into any of the documentation stuff is simply that we're going to see in a moment, but Leo is entirely based on, actually I'm going to load up the white paper for this because I forgot to do this earlier. These are the lovely people that made this back in 2021. Oh god, this white paper is fucking huge. Let's see. I'm just going to jump straight to this. We begin describing the design of Leo after introducing the environment with Leo programs. We decided to overview the syntactic language in second two. So Leo programs execute in a... Actually, let's look at something else first. So basically, Leo is based on Rust. We've encountered Rust before. but I don't think we've ever like sat down and explained kind of what Rust is and what makes it unique. And so here's our last video of this stream that is a extremely good, concise, like, this is the shortest video we're going to play about what Rust is so that we have a better understanding of Leo, where it comes from, because Leo is the son of Rust. So let's finally do that deep dive into what Rust actually is.
Rust, a memory-styled program, delivers high-level, low-level performance. It's a popular choice for building systems where performance is absolutely critical, like game engines, databases, or operating systems, and is an excellent choice when targeting WebAssembly. It started as a side project of Great-On Hoare in 2007, who named it after the Rust fungus. It was sponsored by Mozilla in 2009, and has been ranked the most loved programming language every year since 2016, with its fans being known as Rustaceans. Traditionally, high-level languages provide a garbage collector to nerf your control over memory management, while lower level languages provide functions like free and allocate to shoot yourself in the foot. Rust takes a different approach. It has no garbage collector, but achieves memory safety with a concept known as ownership and borrowing. By default, every variable in Rust is immutable. This allows values to be used in the stack memory, which has minimal performance overhead. However, mutable values, or objects with an unknown size at compile time, are stored in the heap memory. Every value in a Rust program is assigned to a single variable known as its owner. When that variable goes out of scope, the memory allocated to it is dropped automatically. In some cases, though, you may want to pass a reference to a different part of the program. Borrowing allows you to access a reference in memory without taking ownership of it. There are a ton of rules to go along with the system that the Rust borrow checker will validate at compile time. These rules keep your code safe while providing absolute control over performance. Rust also has a package manager called Cargo, where each individual package is a crate. To get started, install Rust, then run cargo new from the command line. In the main.rs file, you'll find a main function, which is where the program will start executing. Declare a variable with let, followed by its name and type. The value can't be changed or reassigned by default, so add mut to make it mutable. The name of the variable is the owner. A reference to its location in memory can be borrowed by other parts of the program by prefixing it with an ampersand. Then use a macro like printline to log the value to the standard output. Rust also comes with a standard library that contains modules to handle I/O, the file system, concurrency, among many other things. Now compile your code to an executable with the Rust compiler. You just built a memory-safe executable that can handle the most performance-intensive system requirements. This has been Rust in 100 seconds. Hit the like button and subscribe if you want to see more short videos like this, and leave a comment.
I want to make a note that before anyone makes that comment, yes, the Rustaceans did call their whole repository system STD. Because of course they fucking did. But I thought that was a pretty good summary. Just to add some more tidbits, again, you often encounter Rust in like multiple complex systems, such as games and operating systems. And because of its flexibility, it's also done for a lot of like management, sort of like web server systems for web development. And another thing about Rust that I'm familiar with is that unlike like Python and stuff, which has to like have its own compiler, when you make Rust programs, you don't need to have like other compilers or stuff that specifically works with Rust. A Rust program should just work independently on most systems, so it has really good compatibility between different operating systems and environments. And again, Rust also doesn't have a garbage collecting system. Instead, it makes two different memory pools that, depending on the dynamicness of how you structure your program, it will either automatically check balance stuff between the two memories, or you can pull something from one memory system to another memory system instead of having one giant pool where things can get lost, confused, and eventually bugs, errors, exploits, and crashes happen. And Leo is based off of this, so let's kind of do a little bit more looking in Leo. According to them, Leo programs execute in a ledger-based system where users can execute offline computations and produce transactions attesting to their correctness of these computations. At its core, Leo produces state transitions about zero-knowledge applications. These state transitions are then encrypted into privacy-preserving transactions that are broadcasted to an open network. So basically what it's saying is that your average Leo program will offline be able to do the whole zero knowledge proof snark calculation, and then those computations, when they're in transition, are encrypted, uh, are able to do those computations encrypted, and then are then broadcast to the rest of the network. So offline does all its calculations, so it's sandboxed your machine, then through its ZK encryption method, it is sent out into the world on the network. And that they're designed to achieve several security goals. Informally, Leo ensures execution correctness, meaning malicious parties cannot create valid state transitions without access to the private key and application state of the user, which is why Trail of Bits made that whole note about declaring the key before. In addition, Leo offers execution privacy, which ensures transaction reveal only the information that is intended to be made to the public from applications. So, normally when you have to like implement ZK into a framework like in Solidity, you have to actually tell it, like, basically have to like blurt the information out of there and then actively redact it. It sounds like here you always have direct control of whatever information is passed and displayed, which is really neat. And again, having two pools of memory based on Rust would help with that. Lastly, our approach achieves transaction non-malleability, which protects the transaction from modifying from malicious parties in transit to the ledger, so man-in-the-middle attacks. Let's see. Abstract syntax grammar with abstract syntax trees. And the concrete syntax, so that's its two types. Leo has scalar types and aggregate types. Values of scalar types that are atomic, while various aggregate types contain other values. So it's basically atomic and non-atomic. It also has Booleans and signed and unsigned integers, which makes sense because, again, this is done for blockchain. Whole ass list of integers and types there, including tree systems. Let's see what else can we glean from this. Let's look at the dynamic semantics. Dynamic semantics in Leo describes the execution of Leo in terms of an abstract machine with computational state is manipulated by expressions and statements. This is similar to other programming languages independent of the zero-proof knowledge orientation in Leo. This is intentional so that developers may write quote-unquote normal programs in Leo. Computation and execution of their programs familiar terms while compiling programs transparencies to R1CS. So this is the basic computational state that allows you to just write applications before you go through the entire blockchain system. So you have one frame, so you have multiple frames, and in each frame there's a cell, and in each of those cells you have function, self, and scopes. And in that scope you have multiple variables, including the name, the value, and the variability. So that's what's being computation is stored in each block in a frame. So that's kind of how its whole setup is. And then it says here, even though Leo appears to be an ordinary programming language, it is specifically designed to efficiently compile zero-knowledge applications written in Leo to R1CS. Again, what I like about this is that it's literally a language that is designed, it seems, base level for security. Writing the language itself, you are automatically forced into security concepts, which is kind of fascinating. I'd like to see that in other things outside of blockchain. The fact that the Leo program is compiled to R1CS means that there's an R1CS instance associated with each Leo program. With regard, this is an R1SC semantics of Leo. We emphasize that ordinary programming languages do not have what R1CS semantics, meaning their ability to enforce correct by construction programs or achieve verifiable computations. Meaning, when you put this other coding environment, it makes sense in of itself. So that works. Let's see here. So let's see, the main function does a dynamic mathematical function. So y equals f times x, where x is the input. Okay. So let's see if we can zoom in even farther here. So with here you have x being the input. Oh, sorry. X being the input, and y is the output. So it's like y. So it's like the input times whatever variable you have for x will equal y. For simplicity, we consider a Leo function with a single input and single output here. But it's easily generalized to multiple. So it can do multiple inputs and outputs. R1CS relation is a set of constraints over a set of variables in programming language terms. R1CS relation is synthesized from a Leo functioning composed to function input variables, function output variables, and auxiliary program variables. So let's see here. We have input called X, and then we have one output called Y, and then one auxiliary A, which can be generalized each kind, which then would result in R. Okay, so that makes sense. So let's see, relation by quantifying the over the auxiliary value can define an input-output relations for the one RC. So let's see. So okay, we have the XY for input. Oh, we have the XRY way for input there, right? And then let's see those variables. So when you input this thing, the correctness RCP mirror mathematics expresses this. Okay, I see what's happening here. So again, you have the input output, which results in that, which we can translate over to that the input will equal of the output, and then compare it to auxiliary for input output. So automatically does that when you run the R. That makes sense. Okay, so it's a very concise system here. So it says if Leo computes output Y from input X, and the R1 CS is satisfied by input X and output Y. If the RSSC is satisfied by input X and output Y, then Leo computes output Y for input X. That is, the R1 CS represents all and only the Leo computations. Very interesting. That's how it's able to be dynamic. That's cool. Of course, because it's a programming language, has its own compiler, has a proof generation system. Ooh, let's cover this, and then we'll end it here. And for everyone who wants to do their own research at home, I just put the PDF in the chat. And I think this will be a good time for Eddie to remind people again, I'm trying to raise money for the Doctors Without Borders to help sick and injured kids, parents, elderly people in Palestine, both Israeli and Palestinian, as well as natural disasters around the world, because basically we're heading towards World War III. I just put the link again in the chat for the Tiltify. You could donate in fiat or cryptocurrency. No matter how much money is donated, even if it's an extra $1, that will help towards these volunteer doctors who rely entirely on donations. And you get I get notified when you donate. I worship you during the entire stream. In between streams, I bring up and worship you. And because we're crypto barons, you're not just stuck with fiat currency. You can donate in a ton of different crypto via the Giving Block. And we don't touch any of the crypto or the money because it's handled directly through Tiltify, which is a award-winning, very trusted source within the charity community, which is why we work with them, because we want to use the best for when we want to actually us hack the planet and have us hackers help a cause. So if you want to click that link, if you're on Twitch, scroll to that widget or scan that QR code that I promise is not man in the middle of the deck, and donate even just another $1, because we're like literally $15 away from halfway through our goal. I'll be very happy. So let's do another like 10-20 minutes of this. Let's see, Leo coding text tells if Leo grammar is validating. So there's parsing, and the ATS goes through, which could be non-canonical. And the conversion goes from ATST to the ASG. And it's not a one-way conversion. It can go back and forth, but let's continue on. Analyzation, AGS, type interface, consent programming, loop binary circuit system, and the R1 circuit. So it goes through so many different conversions and checks before it even reaches the main circuit. That's impressive for the compiler. And again, here's that sort of mathematical loop that they're showing here with the different proof systems, particularly between the compiler and the two different conversions to JSON that ultimately generate the proof that then gets sent towards the R1 CS, as we covered previously. I'm not going to get into parsing. Again, I posted the why is my throat acting up? The PDF in chat if you want to just nerd completely out on the rest of the thing, but we're on a time limit, so let's try to finish this in about 10-20 minutes, especially because of, again, I would normally sit here forever, but one, we're 2 hours late because of a fucking browser issue, and two, I'm under the weather. I promised that we're going to be doing 3 Crypto Barons episodes in February. I will be fine and pepper, and actually the first one we're going to do, I'm super excited for, and I can't wait to announce that. So let's continue on. Let's see here. So let's look at some stuff that Leo has built. So for example, there's the Leo wallet, which uses, if I remember correctly, they are browser extensions. So this is, let's see. It's only available for Chromium-based browsers, so it's only on Chrome, Brave, and Edge. They hope to do mobile support. We're on Firefox, so I'm not going to install and test it here. But yeah, it has its own wallet system called Leo Wallet. Baloney. Making these cookies. That's hilarious. We're going to reject the cookies. This is an absurd dice game that someone made on the network. It's a Baloney is powered by the Zero Knowledge Gaming Toolkit developed by Korea on Aleo. This toolkit uses zero knowledge proofs to allow players to prove that their statements are valid without revealing the statements themselves, which is perfect for the game of Liar's Dice. That's kind of neat. Best buffer wins. It's creator's choice. We're not going to play the game here, but that's kind of neat that, you know, someone made a fun sort of proof of concept video game out of this. Why can't I scroll up properly? Huh, that's weird. Being hacked! And then the Leo programming runner, which we'll look at later because let's actually observe the language first before we do this. So, Leo programming language. Let's look at all of this here. So, other platforms, let's see. It's build Leo from source code. So let's see here. So here we get to the actual coding part. So I get to do the thing I've been dreading and turn on terminal here. So this is our lovely terminal. This is as big as it gets. And let's let's try installing Leo. Actually, let me just double check one other parameter before we get in there. Let's see. Welcome to Leo programming language. So we already have Git and Rust. So we're already good at this. So let me go back to the original tutorial here. So let's first make sure that we have Git properly installed. So Git version. Yep. And then we have cargo, because we already have Rust installed. Oh, I typed it wrong. Sorry. Yep. It's built from source code. So first, let's git clone. See, when I'm under the weather, my typing gets all like jittery. So we're gonna copy paste that in. So we're gonna git clone the whole Leo repo here. We'll futz around with this until, let's aim for like 1050 at max, depending on how fast or slow all this goes. So right now what we're doing is we're installing Leo. So many fucking objects. I'll tell you this has been like we have so many interesting conversations here at Hack Manhattan, especially during the open houses, that like apparently there's a rule of like that we can't say the term podcast because, you know, it's stuff so interesting that we were like, let's make a podcast. And like it kind of sucks because look, while I love doing this and interact with you guys, I keep hearing what they're talking about and I'm like, I want to interact. It's like the sad man looking through the window in the rain sort of thing. All right, so now that that's installed, let's cd and well first let's list the different stuff here. So Leo should be in there, so we can cd into Leo. And now we're gonna build it, and hopefully this will not go as long as I hope it is, because fucking Rust takes forever. So we're gonna cargo install path. Oh, we didn't. Hold on a second here. Let me just double check something. Making sure here. Almost supplied? Alright, so we've entered our first problem here. Let's figure this out. Oh, I'm sorry. The path's supposed to be like the root folder, so it's the dot. Here we go. So now we're doing it. Fetch. Fetch me my cargo, boy. Here, boy, come catch. Good boy. So now we are installing the Leo language itself. It's going to take a little bit here. This is so neat. I'm so happy to be back during this. Again, it's kind of weird because like this month, like we basically had one Master of Unlocking and one Crypto Barons, and like if everything goes well next month, it's gonna be 3 Crypto Barons, 2 Masters of Unlockings, and a Partridge and a Pear Tree. Now, at absolute best, we will actually have a physical meeting. If not, I guarantee we're gonna have a physical meeting in March for our 7-year anniversary. I still can't believe that we founded this in 2017, me and G.I. Jack, 7 fucking years ago. I feel like goddamn Elrond, if like I was there 3,000 years ago during the second age of man sort of bullshit. Alright, so everything's compiling correctly. Let's cross your fingers. No whammies, no whammies. While it's building, again, I'm going to remind, while I like torturing myself like this for fun, I am, again, trying to raise money for Doctors Without Borders. Here's the link that you could do for donating chat. If you're on Twitch, you could scroll below and hit and click on the little widget that we have on Twitch to donate, or you can scan that QR code. Although you should always use instead of scanning your QR code, by the way, through your phone, which will immediately open the link, you should always use like a QR code parser, just like any QR code scanner, which will show you the URL before it actually opens. That way you know if it's like man in the middle type of shit. But it's safe to scan. It's going to bring you to Tiltify. They handle all the money. We don't for the charity to donate to all these doctors who are helping out in Palestine and around the world. We're doing this again until April 1st for April Fools. And, even if I get $1 this stream, or like $3 or $5, I'll be over the fucking moon. Although if you want to take Murph and donate like $50.51 or do a calculation so it reads $69.69, which someone one time did before on a charity stream, that would be hilarious. But either way, when you donate, we shout you out on live stream, or if it's in between streams, social medias, I cheer you on. I also, by the way, get notifications when you follow us on Twitch, YouTube, PeerTube, Odyssey, and Kick. Sorry, not PeerTube. I shout you out when you follow us on Twitch, YouTube, and Kick, because we get notifications for that. We do get notifications for if you watch us on Odyssey and you donate the Odyssey crypto tokens, but no one has done that yet, so whatever. Alright, I hope this finishes anytime soon, because we going on my original time plan. We only have 10 minutes left, which is fine, because I didn't really want to do much. I hope this is not one of those episodes where I realize, oh fuck, I probably should have did this beforehand, because I do like watching things build together and compile. Especially because we're not, the only way to make this is to build it from source, so. Worst comes to worst, I'll just turn on the music again as we watch this compile. And I think this is so far the first time we've ever compiled something with Rust, where usually what happens is that everything compiles instantly, and then there's one build that takes like 5 billion years, and that hasn't happened yet. So it's nice that it seems that they've like chopped up all the data correctly for this. By the way, also miscellaneous things. I am so fucking glad that like the same friend I was talking about that works Trail of Bits, they got me the COVID test, and I'm just so happy that whether this is allergies, weather changing, the demo gods hating me or whatever that's caused my nasal congestions, I'm just so happy that it's not COVID. In fact, ever since I got Delta, oh boy, just heard a fun conversation outside. Ever since I stupidly got Delta in the dumbest, worst way possible, because that was like a whole controversy. Not because, again, everyone knows DCG201 stands on the whole COVID-19 thing. We're not anti-maskers. We are very pro-science. But basically, I got vaccinated, and this was before the new boosters, and this is when Delta came out, and I got Delta because someone at a thing incredibly fucked up, let's put it that way. But ever since then, and then I got my following boosters, I just never had COVID since then. I've had gotten food poisoning and a bunch of other things. I also haven't gotten monkeypox and got vaccinated for that. My whole thing is I update my body in the same way I update my computers. And I hope there's no vaccine that is as slow as fucking Cargo building everything from scratch, so come on. We're almost there. It's like 378 to 460. See, this is when usually shit starts slowing down. This is what gets me nervous. It'll be like one build, and that like one build takes 5 billion years. But no, the number's moving. Come on. Okay, there we go. 380, 381. By the way, honestly, I'd rather have something build consistently every like 10 seconds than to lightningly go to like nearly the last number and then hang up there before the last number. And my favorite is when it'll reach something like 499 out of 500 and then do a critical error right there. And so all the other installs are null and void. I fucking hate that. I've had that happen on streams in the past. Alright, so this is the part of the build where like things start slowing down. So even though we're close, I think what I'm going to do is I'm just going to turn the camera off, set up some other things, and we're going to listen to some music while watching the rest of this build. So stay tuned. I'll be right back. Enjoy the music while you watch the rest of this build. We don't have much to go, so it'll just be like a minute or 3. not one of those things where it's stuck because we're live streaming and then you live stream. It's fine, it's fine. We might have to end this at some point. Hang on. If this build does not resolve itself in the next 2 minutes, I'm gonna kill this terminal and then we'll try it again. Holy shit, we actually made it. Let's kill the music. Stop the fucking music. I always keep forgetting how fucking long it takes Cargo to do shit. Alright, let's turn back this webcam here. There's my face. Alright, so finally got all that done. Still way less time than the whole server error thing. So now that we have Leo fully installed, we can test to see if it's here by just simply typing in. Actually, first let's list everything in here. Yep. And if we type in Leo, it should just run. Yep, we have the command now. So now let's create sort of like a new program here. So we're going to call it Leo new hello world. So that should be in there now. We can see it over here on hello world. So we're going to CD into it. And in hello world, we should have multiple different things in here. Let's see. So let's see. It should be a readme build, CD into build. Sorry. I think we can open the main thing in Nano. Yep. So that's the syntax to the circuits right there. We have the hello world program here, which is function hello. inputs right there. So that all checks out. And let's look at the program itself in JSON. Yep, that's all JSON parameters. So let's see here. So we're going to exit out of that. I'm trying to remember. Let's look into the source. Here we go. This should be the main program. There's the program, yep. So our main program here, which is represented the zero knowledge proof stack of it. Here is we have program hello world.aleo, transition main, and we have the two asynchronizations with U32 A and B, which should equal to U32, and then A and B, yep, equals to 32, and then we return C. So that all checks out. And then now that we know that everything's there, let's run the program and see what happens. Let's see. Pile main Leo no show. Failed to execute run command. Expects 2 inputs, but 0 were provided. Ooh, there was an error in the example program. Let's see. See if everything works out the way it's supposed to. It also might be the JSON. Program, transition main, public. Yeah, this looks correct. Is it the JSON? Let's look at what the JSON should list. Yeah, no, that completely checks out. All right. Even though we got an error, let's do that. Let's see if we can clean the directory, which should just be this. Okay, and actually let's try that command again. Weird. I wonder what the error is. I wonder if by updating it, we can cause something to happen. Okay. So it's already, that's good. Maybe we need to execute before we actually run it. Okay. Interesting. I feel like I'm missing a step here. Hold on. Oh, I think I have to actually run the actual U calculations. So hold on. Leo run main. Let's specify here. And then, so we have a 0, and we're gonna do a 1 of the U calculations. Let's see what happens. There we go. So now if I do, okay, so just running it, because we didn't put any parameters for the inputs, gave us nothing. By actually letting what the parameters are, by adding the 0 to the 1, it made that. So actually, if we did Leo run main 1U 32 and then a 2U 32, let's see what happens. Yeah, it should be 32. Exactly. So that all works. It's just we have to actually declare the U variable. So that just running it won't work. So that's interesting. That's like a little taste of the Leo language right there. Let's see what else we can run here. So another thing that we can look at here is real quick, because now that we got most of the big stuff out of the way, is hang on here. Let's quickly look at the SDK. I'm going to bring up the web browser again. Nope, hold on. So the SDK is the actual D application platform. Hold on a second. I haven't told you about the audio. What's wrong with the audio? Let me listen. Oh, the buzzing? Sorry about that. This will occasionally happen. Let me switch to the less higher quality. Okay, this. Okay, there we go. Oh, whoa. Let me bring that. Sorry, I made you deaf there. All right, so this one is. I'm probably gonna sound like I'm underwater, but you'll be able to not. You'll be able to like hear me better. Also, if I sound scuffled, it's because I've been having whole nasal congestion things. I don't know if I'm sick or it's the weather or whatever. So thank you, computer. I don't know if I'm so busy. I've been so busy the past 2 months. Never mind this week. Like I was at a blockchain thing every week, but like I miss your streams. I feel like you like never stream anymore. So thank you for like stopping by here. And actually, before I go to the Aleo SK, I want to take the reminder again that we are raising money for Doctors Without Borders in order to help all of the injured people, especially the children, whether it's the direct warfare itself with bullets and knives, or with the increasingly worse sanitations for both Palestinians and Israeli citizens who are suffering with this needless, stupid war between the Hamas terrorist organization and the Israeli Defense Force, which is basically if fucking Mongo was a Jewish ethno state. And so we're raising money because these doctors all volunteer their work and they fly over and they retire land donations. You can click that link, scan the QR code, or do the little widget that we have on Twitch. If Even if we don't make our goals by April 1st, which we're honestly $15 away from halfway through our goal, all the money gets donated anyhow, and you can use both fiat or cryptocurrency through the giving block, and we don't touch any of the money. That's all through the trusted third-party Tiltify. So it's great. So working full-time again, not streaming as much, trying to do a computer security news stream every week though. Cool. I will try to catch up on that. It's funny because one of the things we're looking to bring back, yes, tech is political. If you want to get involved, by the way, in the we have a overall donation group. I'll send you the links to that tomorrow. I'm going to put a note about that if you want to get involved with the live streaming, because we in February we're going to start reaching out to other content creators so we can like pool the money together to help all of these fucked over people, because when we say hack the planet, we mean it literally. But it's funny because we test piloted a show a while ago called Patch Tuesday, which is supposed to be the last Tuesday, the first or the last Tuesday of every month. We recap all of like the cybersecurity news, and so I'm going to try to restart that maybe in March. So let's see for that. But I hope when you do stream, I hope it's good luck out there. We're going to be experimenting with other types of streams, including one next week for crypto barons. And both of best of luck for both of us. But let's try to finish up the episode here because we're going way past the time that I wanted with the Aleo SDK, which is the actual DApp application about this. This is where you can do the coin credit system. This is where you can make all the different applications using zero proofs and stuff like that. So let's bring up the terminal again. Let's try some things here. So I'm going to CD out of everything. And let's build this thing. So first of all, let's git clone this motherfucker. So let's copy the URL. Git clone badam. Just take a little bit. Pretty long git clone, to be honest. Usually git clones are like that, even when it's like gigabytes of data. But I guess there's so much here. We're very close. Hopefully, it's not going to go as long as fucking cargo takes. Jesus goddamn Christ. Sometimes I wonder what's more annoying, cargo building shit or npm installing shit. Which is funny because guess what we're going to be using in a bit once this thing fully loads. Nothing like npm fucking update loops. Am I right? So here we go. So now that we're in that, we should be able to cd into the SDK. And let's just build a general app here. So we're going to do npm create, as we call Aleo, and the latest release. Let's see how long this takes to build. What we're going to do is we're going to do the SDK. We're going to look at some other programming examples. And then we might attempt to run a node because I'm worried that running a node might crash this whole system. And then we're going to end the episode, basically. All right. Yes. So we're going to go through some prompts here. So let's just call generic Leo project. Which framework? We want vanilla, React, or Node.js. God, this is like a Russian roulette. I don't want to deal with either React or Node.js. Let's just do vanilla just to be with this. So let's select the variant. There's only one variant, which is JavaScript. Okay, so I just need to update npm. Let's do that while I'm thinking about while it's prompting me to. Because it's been a while since I've loaded this terminal. Go back to the SD project page. All right. Funding npm fund. Because I'm saying something else up here too. Just poking around. So let's see. I want to try something really cool here. Let's try to do a. Since we picked JavaScript, let's try to do the WASM, the WebAssembly interface with this. So let's see here. So. All right, so let me just make sure that Rust up isn't. Well, no, Rust is installed. So this is going to be interesting. So we're going to do yarn add dev. Oh, first of all, hold on. Let's see what's created here. Yep, so we have everything here for that. So now let's yarn this. Dev and sorry, it's a dash. Rust. Okay. All right, so now hold on, let's see what's in here again. Is there a roll up here? Hold on. Trying to look for a specific thing here. I see package, I see style, Vite, worker. I don't see a roll up. Hang on. So I'm gonna just install this with npm, and then I'm gonna add another folder into this, and we'll see what happens. It's amazing how npm is faster than cargo for no fucking reason. All right, so let's look for it again. All right, let's try this. So we're gonna go into the roll plugin. All right. Let's try example first. Yeah, here's the roll up. Input Rust. Export default cargo. All right. Just look here. I think we're good with this. So now that we have that running, let's build this and see what happens. I'm gonna yarn build. Okay, I need the CD out of things. Hold on, let me see where I was. Hang on here. No, it should be in here. What the fuck? There we go. So we're back here. Um, there we go. All right, so now we're building in the right folder, which is the Aleo project. So we got that done. Now let's test it. Let's test it in browser. Okay, that wasn't it. Well, that didn't work. Well, at least we tried to, because I wanted to bring up like the web page and showed how the SDK system looked. So the last things I'm gonna do is, by the way, on Twitch, I have this pinned to, we have a GitHub widget. So if you want to follow along with these repositories, we have them posted there. I'll open up new windows. You can look at the same stuff that we did. Aleo also has a whole example workshop thing going on. So let's CD into Leo and so let's import the workshop examples. They're all on here. So now we're going to install. It's already installed it, so it's probably going to get a little confused. Might have to restart it because I might have confused it since I already installed Leo. Let's find out in a couple of seconds. Let me just double check something here. Okay, here we go. So it's doing Leo again. Might take a minute. Oh god, don't tell me we're building all over again. It's gonna take forever for me to get home, aren't I? This is wonderful. Well, while it's building all over again, let me remind again that we're trying to raise money for Doctors Without Borders. I'm going to post the link in the chat once more. You can click there. If you're on Twitch, you can go and click the little donation widget, or you can scan that QR code. And it's handled entirely through Tiltify. You can donate with both fiat currency and cryptocurrency, because crypto bears, of course, we focus on the crypto. And we're literally 15 bucks away from our goal. Even if I just get $1 this stream, I feel like this will all be worth it. And even if we don't make our goal by April, all the money that's donated is still going to be donated to these brave volunteer doctors who are being deployed in Palestine to help Palestinian and Israelis who are wounded because the IDF is terrible. Same thing with Hamas, as well as also various disasters around the world. And depending how the U.S. election goes, we might be the next disaster in that. So, just putting in perspective right there, especially with this whole like Texas state succeeding craziness, which I really think is a lot of like posturing, but we'll find out. All right, let's see how this goes with compiling. The problem is that this is installing Leo, but like I think like it's like does like Leo and Aleo. Let me double check the source code here. Okay, I think we have to go through all of this. We already started, so hopefully this won't take as long as last time. Famous last words, I know. When we do this, let's look at the token example. Since this is crypto barons, we might as well look at like transparent shielding custom tokens. So that would be a pretty neat example. They also have like a tic-tac-toe game, a battleship game, a voting consensus game, and things like that. Why is when I promise when I'm on break, my throat's fine. I don't cough. So as I'm on stream, everything happens. It's a fucking nightmare. You know what I'm gonna do? I'm gonna put the music on again. So give it a couple of minutes. I'll be right back. Nope. Dr. J's annual chat about this. Annual chat about what? Um, there's nothing annual about this. This is for finally doing episode of Crypto Baron. It's only going to be one this month, but in February, which I'll detail more at the end of the episode, hopefully in the next 10 minutes, we're going to be I'm going to be talking about the 3 episodes of Crypto Barons that we're going to be doing. So that should more than make up for the lack of episodes this month. But in the meantime, we're going to let this continue to compile. I'm going to put the music on. I will be right back. Still available in chat though. Oh yeah, no. Again, what we're doing is I'm torturing myself with this D-app development platform whose language is based off of Rust because, of course, it fucking is. And we're trying to raise money for the Doctors Without Borders, and there's the donation link. So, like, even if even if you donate $1 during the stream, I'll be like really fucking happy. Let's put it that way. But I'm gonna go rehydrate. I'm gonna put on some music and wait till this thing is done building. So I'll be right back. This is already going a lot better than last time. We're almost there. we have to make it. Swear to God, this process doesn't make out. I'm going to throw Leo into a pin. We have to cancel this. I'll just wrap it up and let them do it. Actually, I have a different idea. Let's turn the camera back on and leave it. Okay, so while this is hopefully finishing up its last bit here, what I'll do is I'll take the terminal off, and I want to look at one thing I was going to save to the end, which is that there's an actual web interface for Leo that allows you to play in browser. So I think this is kind of neat. Leo is functional frontend, designed by private applications. We have an example section, so we find examples of Leo programs, translation functions, transition functions, so you call that for inputs. And there's the JSON that manifests the file. And then the .env, which allows to know like the private keys and what network it's running on. Here you can paste the bash commands, each step of the program, and the project name. And anything you edit here, you can download the project, or you can reset it. And then there's a resource tab for GitHub documentation. There we go. So yeah, this would be like the command to run the thing. This is the same program that we ran the first time. Nothing really going on. The JSON here, well, there's the parameter list, and then the env is just the testnet and the private key listing, and that's the example to run it. That's the hello world one. What we're going to look at, if everything goes well, is a simple token, which will show how you like generate the tokens with the names and everything. I think that's pretty cool. Did it finally finish? Yes, it finished. Okay, so let's turn terminal back on and wrap up this episode. So everything installed. We have all of our work examples here. CD into token. And let's run the token program and see what we can generate here. Actually, before we do that, hold on. So we're going to nano into the main program. So you see all the programming of the different tokens. And then those are the parameters, which really haven't much changed since last time. There we go. I figured out how to back out of it now. Look at the source here. Let's look at the main program. So this is the main program here. As we can see here, address record token, finalize mint. And then this initiates with a new record on the chain, transfer functions. Very comprehensive program here. And now let's run it. Whoa, that's cool. This happened so fast. So they're converting for you Bob's token, so it's just passing back and forth. So let's review of what just happened here. The bank example. So we ran it. So we have the private key of Alice and her address, and the public key of Bob and his address. We're going to play Alice. We swap her private key in the public mint. So we give her 100 tokens. We add the constraints, and then here comes the output. So it's the amount of finalized functions of the mint underscore public, which takes the argument Alice address and the amount of tokens publicly. The information shown on chain can be quoted on the network here. So Alice has 100 tokens, Bob has 0, and that's the private balances. Let's mint 100 tokens for Bob, so we switch to the public key, so they echo it on the test net. Main Leo mint. So we have both a public balance and a private balance. Now let's transfer 10 tokens from Alice over to Bob. So now we run the transfer public function. So we have both the two public keys. And because we can cross-reference the private keys with the ZKSnark, now Alice went from 100 to 90 and Bob is to 10 publicly, but Bob still has his 100 in the private. And let's privately transfer 20 tokens from Bob to Alice. So using that same ZKSnark system, we took 20 from Bob's private. We sent it over up to Alice, and now Alice will have 20 private tokens while leaving the public balance same. So it's interesting how you can have like two balances in terms of coins, which is also pretty neat for like separating two tokens between like the actual exchange tokens as well as like the validators. So that makes sense. So yeah, I'm not going to run through all the examples, but that was just one. Maybe we'll return to it later. The absolute last thing I want to look at here is, well, first of all, this is the Leo program runner. It's a Python package that bridges the gap between Leo programs and Python environment. Apparently, it runs by parsing the source code of a Leo program, dynamically constructing a Python class based on its contents. The structs and records denied in the Leo program represented by member of variables, and during the transition phase, as we saw earlier. Installed through pip. I am not doing that. But it's a very interesting function. And then finally, we can't really run the Snark VM, which is the platform that's based on, but let's see even if it crashes, if we're in Snark OS, and then we're going to end this entire stream. So let's find out. So let's CD out of everything. We're going to CD into Leo, and we're going to git clone. Okay, and we're going to CD in Snark OS. Hope this doesn't kill the stream. And see all the folders here. And there's a special build for Ubuntu, so we're going to use that. If it takes too long, we're just going to end the stream early. God, I wish someone would donate $1 tonight. Oh, you have to run it in root. I'm dumb. Do I even Linux, bro? Now we're building. But yeah, basically this would allow us to run the node system. There's no real, if I remember correctly, like staking coins or anything. This just allows us to run a node, and we can use the whole command line interface for it. And once this installs, or is close to installing, I'm going to end the episode here. Because we could do more. We could fucking run an Aleo client, an approver, and everything. But I think we've run this episode as long as this course. And I'm really tired, and I have work tomorrow. So yeah, you know what? I'm going to end the episode here. Let's go back to face. That's the end of the episode. So that was Aleo, which is a and by the way, this was the URL for the Play Leo Lang, which is a way to build decentralized apps with ZKSnark and privacy as its base focus core, using a programming language that's entirely based on Rust called Leo, where the actual privacy system is built into the programming language so that you can't basically undo the privacy out of it. And I thought this was an interesting journey, which we started on time. But, you know, this is how these episodes go. So, again, thank you for all watching. One last time before we go, because you don't have to donate during the live stream. It's just fun to do so. But up until April 1st, we are going to be raising money for Doctors Without Borders for the conflict in Palestine, with these doctors running entirely on donations, treating injured and sick people, mainly children in Palestine, both Palestinians and Israelis, as well as disasters around the world since World War III seems to be starting everywhere. You could donate in fiat or crypto via the giving block. All the currencies handled through Tiltify, which we don't touch, so it's all kosher. And even if we don't make our goal by April 1st, all the money is still donated to help out these people in need. So you can click that link. If you're on Twitch, you can click the little widget, or you can scan the QR code while this stream's running. So, yay. I thought this was neat. I know I'm just tired and congested, but this was really fun to do. And I know we only had one Crypto Barons, but I have good news for you. We're going to be doing multiple Crypto Barons, 3 of them, in fact, in Feb. So let's look at the calendar. So we're going to be doing a Crypto Baron special on February 4th. We're going to be making that announcement later this week of what it is. I'll give you a hint. We're going to be interviewing some really awesome computer security hackers that work in the blockchain. I'm so excited for this. And then we're going to be doing the next Crypto Barons, which will be a normal one, on February 17th. And then in March 2nd, we're going to be back to normal with Crypto Barons happening on March 2nd and March 16th. So look out for February 4th and February 17th for our next episode. I'm sorry I meant for 3 in February, but I was supposed to be there, but February is kind of short. But I'm really excited for the one on the 4th. That announcement's going to be fucking huge. And then we're gonna resume normal operations on the 17th and then go on. Our next Master of Unlocking is going to be February 10th. That's also going to be very special. So we're going to be announcing 2 special things later this week, which is really cool. And at worst, by March for our anniversary, we're going to have our in-person meetings. I have a lot of stuff lined up this year for DCG 201 to get back to form. So I'm excited. Anyhow, that's the end of our episode. Thank you for watching. I hope you guys learned a lot and watched me suffer. Please continue to donate to our charity. If you're on Twitch, we're going to raid someone afterwards. If you're on YouTube, stay tuned because it's going to go to a completely different video that I can't remember exactly what we forwarded to, but it's going to be some sort of knowledgeable thing in the blockchain space. But that's our show. We're going to tune out and play the music. Thank you for all watching. I'm Sidepocket from DCG 201. Once again, if you want to check us out, there's our blog at defcon201.medium.com. If you go to our link tree at defcon201, we are on Twitter, aka known as X, because of the stupid Elon Musk. We're on the Host.social and Mastodon. We're on Instagram. We're on Blue Sky. We're on a ton of different social media platforms, and we're also live streaming on Twitch, YouTube, PeerTube, Odyssey, Kick, and we're going to be adding and juggling some new ones starting in February. So hope you check us out there. And if you want to reach out and chat to us, I am Sidepocket on Discord, and here's a link to our Discord. So again, if you're on Twitch or YouTube, stay on. You're going to be forwarded to something else. Once again, thank you for watching. Thank you for Hackman for helping us. Hope to see you on February 4th for our next Crypto Barons. Hack the Planet, Dirty Jersey represents, and remember that, again, when you do the demo gods, notice how easy running all the stuff in Leo was, but a freaking browser compatibility in running the GitHub website delayed everything by 2 hours. Fucking love computers, right? That's why you should test this stuff early and not be me. Anyhow, peace. Thank you for watching. Enjoy the music.